So today actually my people asked to do about infinity limits, or else to do some question regarding of the some question of the limits where infinity come as a either variable or either as a limits function. So basically, there are a couple of places that you can have limits appear. I would say I first write the basic limit first, fx equal L. So here this is actually where your variable range, or where is the position of your real axis, so your domain where you're looking at. This is where you actually function is going on. So either of these A or L can take the values of plus or minus infinity. Basically, if you consider them as I would say real numbers, this A can be arbitrary large positive number, or L can be arbitrary large positive number. So in these situations, basically, if you take an example, let's say something like this, limit x goes to 0, 1 over x squared, we all know from our L knowledge, this goes to the infinity. So in these cases, how do we going to prove this limit and how we going to write its definition? It's actually the trickiest part. I think that is most of the things that you get confused, how you define the infinity, how you write a definition for where your limit goes to infinity, and then how to prove it. In actual case, the proving the limit where your variable or your function goes to infinity is pretty much easier than you deal with the real numbers. Let's say if L goes to plus or minus infinity, solving limit problems for this case is very much easier than you have a real number for your limit value. I will show you why. Right? So if you write the limit definition for this type of scenarios, so then I will just take a generic case. So I can write a more generic case. Let's say limit x goes to a, you have some function, and this is going to be equal plus infinity. First, we take about plus infinity. Forget about the negative infinity. Plus infinity means if you take a real number line, if you go farther to the right, you have plus infinity. If you go farther to the left, you have negative infinity. And in the middle, you have 0. So because then we first focus about this positive infinity, because it is kind of more sensitive and it is pretty much easy to understand what does it mean even if your function goes to infinity. Now, if you write definition for this one, can anyone tell me if you take the basic limit definition for, first we write for this one, let's say this is number 1 and this is number 2. I first write the definition for number 1, the thing we know, right? For all epsilon greater than 0, there exists delta greater than 0 such that 0 greater than this delta, this is E, implies fx minus L less than epsilon. This for actually I write for this one, right? Not for the later case. Can someone tell me what part do I need to change of this original definition in order to write the definition for this one? Because I write this for, this is that thing that we already know. So what part do we need to change? Can someone unmute and tell me? Or even in the chat? I got a message. The second part. Please discuss the question. Okay. I will discuss that question, because before coming to that question, I need to tell you about what does this definition mean and how you need to prove that one, because otherwise you cannot, because there are something called one-sided limit is yet to come. I think it does not be covered to you. If it's covered to you, they are going to be another set of definitions. Then you have to remember around, I would say, more than 20 or 25 definitions just to like do the question, right? Because you have to just to remember the definition if you don't know how to change it. You have to change. If you look at this definition very carefully, this part, right? I would write using this part. I would write using a pen, And this part is describing the range of x. Basically, this part is correspond to this part. So here, if you take, here a is a real number, and here is also a is a real number, and in this case, also I take a is a real number. So if a is a real number, if you focus this part, if this part is same as this part, you don't need to change this part, right? Simple as that one. Basically, this part is simply describing the range of your variable. It is nothing to do with this. Now, if you closely look at this part, I would say I pick another color and I just write it this way. This is your x variable part, and I take the blue color, this part, and this part is correspond to your this variable part, this L part, right? In the first one. So in this case, L is a real number, but here your limit is a positive infinity. Then you have to change this blue part. You have to change this blue part. So how we are going to change it to match the infinity is the game, right? So I write the definition and I tell you what does that mean, right? I write it, I take the blue color, I write for all m greater than 0, and this part as it is, delta greater than 0, such that 0 greater than x minus a greater than less than delta. This is implies, I have to change this, fx greater than m, right? This is the definition for this. So what does this mean is, if you give me any, you can either, because this notation of m is not significant, you can put any number, but I just put m as like I would say a convention, because here, what does this mean is, if you give me any positive number, your function is greater than that positive number. Because usually when you're taking the limit of infinity means, like, because infinity is a very large positive number, so it means that if you can give me any arbitrary large positive number, your function is greater than that one. So basically for this type of large positive numbers, we use the notation m. It is kind of I would say not a convention or a practice, it's kind of, I would say, a preference, right? Even if you need, if you can take capital T or U or any other. So, but in the most textbooks, they use the notation m for that one. So this is actually the definition, right? So there's no absolute value there. We are simply saying, give me any arbitrary large positive number m, or I can find a delta where your x is in between a plus delta or a minus delta, because this means that your x is in the range of a plus delta and a minus delta within this range, except x equals a value. You can find such a delta value where your function within that range is greater than this arbitrary large value. Is that clear, this point up to now? Is it clear, or I need to explain it again? I got some message. Yeah. Now, okay. So before going into the question, this question that I write to, let's say I would say this question, right? This is a simple, very example. Before going to an example using a positive infinity, can someone tell me? I would copy these two definitions over here to the new page. Because if you can understand that one, you can easily write any definition for sequences or one-sided definitions or any other thing that you can do if you know the thing. But if you don't understand this, it's very hard, right? Okay, so I just erase these parts. Right? Let's say this is actually for limit x goes to a, if x equal L, where a comma L are both real numbers, right? So here, limit x goes to a, if x equal plus positive infinity, where a is a real number, right? for the second definition. For third, for example, just to know that where you get my point or not, limit x goes to a if x equal, let's say, minus infinity. Now it is not a positive infinity. How are you going to write that? How are you going to change that? Can someone tell me what part do I need to change? Again, a is a real number. Can someone put in the chat? Like, what part do I need to change? I put one number. I say this part is number 1, and this part is number 2, and this part is number 3. So what part do I need to change? Whether it is 1, 2, or 3. One message. 1 and 3? Yeah. We need to change 1 and 3. Why? When your function goes to the negative infinity, it means it will become arbitrarily small. Arbitrarily small means you can take any arbitrary small negative number, your function is smaller than that. If you take a real number line, if you go further right, it is positive infinity. If you go further left, it is negative. So it means if you give me any arbitrary small positive number further to the left of my like real number line, it doesn't matter. Your function value is well below that one, right? So then we need to change 1 and 3. So basically, we don't need a positive number. We need a negative number, right? And this, the second part is going to be same. And this part is going to be fx going to be less than that positive number a. Make sense? Or do I need to explain it again? You get that part? Hello? You get that part? Is it clear or do I need to explain it again? Yeah. Anyone? So please just note if you don't understand, because just tell me. Okay. So now, if you take these these two, now we're going to do in the example question, right? How are you going to do that? First, going to, I think you guys send me some question as well. But for before we do into that one, I will just very simple example just to make clear how you going to solve that problem. So now we can do our example problem. So this x goes to 0, this 1 over x square. This equals actually positive infinity. We know the limit. So if we need to prove this one, we need to prove for all m greater than 0, there exists a delta greater than 0, where 0 less than x absolute value less than delta. This should imply 1 over x squared, your function, greater than it. So we can first focus on this one, my rough work. I can focus on this one. If I take my rough work, I can have 1 over x squared less than m, and I can have x squared larger than m. So I can have x squared less than 1 over m. So I can have my absolute value less than 1 over root square. So whenever I write in the proof, I would like say, let m greater than 0 and delta equivalent to be 1 over root square m. If you need, you can put the absolute value. And then you can have 0 less than x absolute value less than 1 over square root m absolute value. This implies x squared less than 1 over m. This is imply 1 over x squared less than 1 over m. Thus, therefore, we can tell for all m greater than 0, there exists delta greater than 0, such that 0 x less than delta, this is implies 1 over x squared less than m. Is it clear or not? Sorry, the other way around. So this should be larger than m, right? This is larger than m. So therefore, limit this double implies x goes to 0, 1 over x squared equal to positive. Yeah. In the last step, you have to move m upwards. So I did a mistake there, but I corrected it. So is it clear or you need to explain it again, this infinite limit, before I go to another question? Because I just choose this question just to like, it is not a sophisticated question. I just need to show you, because it is very easy to handle the infinity limits because you don't have absolute value there. Right? Don't have to deal with absolute values. It's really easy to get the inequalities because you can just deal with real number. The only problem is you have to practice what definition to use and what does this actually mean. If you don't know what it actually means, either from these two definitions or how to change it, you have to remember many variants of definitions. Because even these two, let's say you have limit x goes to a f x equals L. Even this part, right? You have a L. You have, this can be real number, this can be real number, and this can be real number, this can be positive infinity, right? This can be real number, this can be minus infinity. So you have 3 different combinations for each. You have actually 9 variants of limits. If you try to remember all definitions, you have to remember 9 variants without, if you don't understand how to change this one, it's not going to be work. When it is come one-sided limits, it's going to be a disaster, right? It's going to be, I think, around 20 or 25 variants you have to remember. That's not going to be work. That's not how you do mathematics. It is, if that is the way if you do mathematics in your A levels, please do change that one, because you will be in trouble. Because you need to understand what is actually happening underlying. Because it is very easy once you get the fundamentals, understand the fundamental thing, and then it is kind of, I would say, pretty much easy to handle the questions. If the limit is L positive, that in the definition, when we can use the, if someone asks about if the limit is L positive, there's nothing called limit is L positive. You have only thing for left hand limits and the right hand limits. There's nothing called L plus limit. But I just need to verify that part because I never heard about it, but I will just verify. The whoever that sent the message, just put me a WhatsApp message, then I will just look at back and see what that definition means. But usually we have something called left hand side limit and right hand side limit, where we only consider, let's say, in this case, we consider your delta, the neighborhood around A is to the A plus delta and A minus delta in left hand side limit. What we do, we only consider the left hand side, and the right hand side limit, we only consider the right hand side. This we called right hand side limit, and this we called left hand side limit. So this is actually the 2 basic limits that you have in the one. We usually call those one-sided limits because we only consider only the one side of your delta neighbor. This is clear? So then, actually, I'm looking for the question that you guys sent over to me. Okay. So now, actually, that question is to have you regarding the x is goes to minus positive or minus infinity. Then I will do one part of that limit as well. Otherwise, you don't understand. Let's say how we are going to write the definition for something like this one. X goes to positive infinity, and your fx, let's say, goes to L, and where L is a real number for now, because we don't need to change many of these. How we are going to write the definition for this one? And I will just going to copy this first one, and this is my original definition for the definition that you know, our basic one. How we are going to change that one? So what part that we need going to be changed, right? So I would say this number 1, and this number 2, and this number 3. What parts need going to be changed? 2. Exactly. Because now here, this part remains same. And only changing part is this variable part, right? Now, you can write, we don't have to change this part for epsilon greater than 0, but you have to change this part. Let's say their x is, I would say, m greater than 0, such that x greater than m implies this part doesn't have to be changed, fx minus L less than infinity. So less than epsilon. Now someone tell me, if I have this limit, what part do I need to change from the above definition? Again, my L is real number. Is it number 1, 2, or 3? Because this is in here, this is number 1, this number 2, and this number 3. What part do I need to change? 1, 2, or 3? Again, 2. Because if you consider these two limits, these two parts are same, but only change about my x. Okay? Now I can write limit x goes to minus infinity. Infinity limit I have to write for all epsilon greater than 0. There exists n less than 0. I just pushed n because it is a negative number, such that x less than n, this is implies fx minus L less than delta. So I forgot to change the color. I will change the color like this. How I change that one? Let me change the color. I can change it to blue. Yeah. So this is the part that I changed. So yeah, is it clear? Got it? Hello, is it clear? Is it clear up to now? How you write the definition? Okay. Now a tricky questions. Let's say I paste the one here. This is the basic definition. Now I will write the definition to this one. X goes to positive infinity and your fx goes to positive infinity as well. So what should be your definition for this one? If it is number 1, if this is number 2, and if this is number 3, what part do you going to change from this definition to write the definition of this one? What part do you going to change? All 3. Because in here, your variable is not a real number anymore, and your function value is not a real number anymore. So then if you write the definition like this way, you have to write for all m greater than 0, the exists m, simple m greater than 0, such that x greater than m, this implies fx less than m. Now, I need a clear answer from you. Do you need to remember 9 variants of limit definition to tackle infinite limits? I need a simple yes or no answer. Do you need, or if you can properly understand this limit definition, are you confident about you can write any of the limit definition just looking at the problem without remembering anything? I need a yes or no answer. Here you go. Only one person replied. Other ones? Is it a yes or no? Yeah. Okay. No? One guy is telling, yeah, no need to remember. Okay. I was like, okay. Now you have a question in your tutorials, one of the tutorials. I think other questions I'm not going to do much because it is quite straightforward, most of them. gonna choose this question, right? It's kind of hard one. Let's see, because this gonna be minus infinity is x cubed plus 1 divided by x minus 2. This implies this goes to positive infinity, right? Okay. Now, if you need to do this question, right? If you need to consider this as this goes to the positive infinity, first thing that you need to do, this is gonna be, it is gonna be, yes. So first thing is you have to get some equation out of this, right? Because first we write the definition. So how are we going to write the definition? For this, we can write for all m greater than 0, there exists n less than 0, such that x less than n implies x3 plus 1 divided by x minus 2 less than m, right? So this is the thing that we need to, I would say, to prove, right? So we have to find some value of n. Okay, so now n should be a negative number as well. Then what we can do, first we consider this part. Start with the rough one. I can take x cubed plus 1 divided by x minus 2 less than m. This is my rough work. And then I have x at two places. So what I can do, I divide both my denominator and numerator with the highest, with the lowest power, because in here, if you take the highest power of your denominator is 1, highest power of your numerator is 3. So I take the highest power of the denominator and divide by both parts. So then I can get this. I can write x squared plus 1 over x divided by 1 minus 2 over x greater than m. This is the thing that I need to, like, I can if I can prove this one, this exactly similar, but there is a catch, right? Because yeah, so I just we cannot do it in this way because the problem is x is a negative number, so the sign need gonna be changed, right? Okay, first because we have to deal with the negative number, that's the problem here. So in here, this number, let's say this power degree 3, power degree 1. And what we're going to do, first we take, let n equal to be, let's say, minus 1, right? Because it's any minus number. So then x less than minus 1 implies I can say x minus 2 is x minus 2 is less than minus 3, right? It can less than minus 3. Or else, let's say, let's say, when leading this question, because we have to be on the negative side, we have to say, without loss of generality, treat x as a negative number. Because it is a very reasonable assumption from here, because this is your real number line. You are moving far towards the left. So your 0 here, you can safely assume your x is, if you are do your calculations while treating as a negative number, it's a valid point because you are considering about going further left of your real number line. So WHM mean is actually, someone asked what if that means is without the loss of generality. It means like we treat x as a negative number, but it is a valid case because we are considering about going further to the left. So we can treat x as a negative number because we need to analyze this function, how it behaves when x is a negative number. So it is kind of, because it is a safe and I would say it is a fair treatment, because if you are talking about negative infinity, it's perfectly fine to treat x as a negative number. If something, what is the meaning of the without the loss of generality? It means like when we are treating x as a negative number, it doesn't make any specific assumption, or if it does not, like I would say, it's not unfair assumption. Basically, it means like it doesn't rule out any of the possible scenarios when x go towards the negative infinity. Uh, it means like, let's say you have a function and you do the proof only for the even numbers, then the proof doesn't hold for the odd number. But here I would say what I'm without loss of generality mean is, if you treat x as a negative number, it has no impact of the final result of your proof. It valid for all of the x of your function where x is near the negative infinity. Because in these limits, we only consider the values near the infinity. Basically, without loss of generality means you don't rule out any sort of possible scenario of your question just because of your assumption, right? It means like it is not like you restricting your domain, or if you are restricting, because it means like if you if you take that assumption and you do your proof, the proof is all for every valid cases. It doesn't rule of any of the valid cases. That's the basic meaning of it, right? Okay. Now, if you divide by this way, so your m is going to the positive infinity, right? So how we gonna do that? Okay. So we can do something like this. First, we have x3 plus 1 divided by x minus 2. We can straight away say this is larger than x cubed plus divided by x minus 2, right? Because it is smaller than. And if we can tell that this is greater than m, that is sufficient, right? Now, now we have the below x. Now what we can do, we can divide this by both sides by x squared, or it's a tricky question because we cannot divide by x as well because it is a negative number. Or else what we can do here, this is smaller than x cubed divided by x, because no, we cannot do that way because the thing is x minus 2, it is a negative number. Yeah. So in this question, if you have access to the limit, the addition limits, and this is kind of very easy, but here you cannot do that as well. Do you have the luxury to use this one? Limit x goes to a fx plus gx is equivalent to limit x goes to a fx plus limit x goes to a gx. If you have access to this rule, if you can use this rule, it's pretty much simplified. But using by definition, it's going to be kind of hard. That's why I'm thinking about, because usually we don't do it that way. Like, do you need to change the limit definition, or you can use the limit rules? You have to prove it. Okay. Now, that's the deal, right? Okay, don't worry. Let's see how it goes then. Okay. Then what you have to do is you only have to take x is less than some negative number, and then it should be larger than some sort of number. Okay. Mhm. Okay. Let's do something like this. Divide both sides by x squared, right? So then what you can do, say, I divide both parts by x squared, so then I would have x divided by 1 over x minus 2 over x squared, right? This is but okay, but I think I don't have this one as well. First of all, let's see, it is the definition of this. X goes to minus infinity. I think limit is wrong, right? This question is wrong because this cannot be positive infinity, right? Because this one is positive and this one is positive. How are we gonna handle that one? I think, let's see, this in the case this is goes to negative infinity. This simply order of x squared. This thing is orbital possible because this order of x squared, if you take the asymptotic assumption, but it is the problem is this is a negative one. In this case, so what we have to do is we have to something like this. In this case, in here, I can write this as I can take x out, x squared over 1 over x and divided by x times 1 over 2 minus. So I can just cancel that out. So then I can have this one, x squared plus 1 over x divided by 1 minus 2 over. Now I have to use this inequality to get something to prove that this is less than any arbitrary positive real number. It can be true. What we can do, let's let x less than minus 1, right? Or let's let n equals minus 1. Then x less than minus 1, this implies 1 minus x greater than 1 minus x greater than 1 over x greater than minus 1, right? Greater than minus 1. Then we can substitute here for this one. Then we can say x squared plus 1 over x divided by 1 minus 2 over x. This is greater than x squared minus 1 divided by 1 over 2 minus 2 over x. This is x less than minus 1 implies this one. Then we need to do something about this one, right? So let's see what we can do. We can have, here is my rougher, x less than minus 1. This is implies 1 over x greater than minus 1, and minus 1 over 1 over x is greater than 1, and minus 2 over x greater than 2, right? So add 1 to both sides, I can have 1 over 2 over x greater than 3, and then I can have 1 over 1 minus 2 over x is less than 3, right? Because it is greater than 3 means it, anyway it is a positive number. So then this is less than 3. No, not 3, it is 1 over 3. 1 over 3. Okay. Now I cannot put 1 over 3 over there as well because I need to have something smaller than this one, right? I need to have something smaller than this one. Basically, what should I need to do is 2, 3. Okay. So basically, yeah. So we can do it this way. I need to have this one is greater than this one. Okay. So without going in this direction, this one, right? We can straight from here, we can write. So we can write x is -1. This is implied. This one, x squared plus 1 over x divided by 1 minus 2 over x. This is less than, this less than 1 over 3. But it is 1 over 3. Let's check. Because this part is not going to be work as well. Because we need to have something less than, we need to have something less than, right? Because thing is like we need to get solve this one, get something larger than, because we need to tell it is a kind of positive infinity. So we need to get something smaller than that one, and still it is larger than a positive number. So we have to get something smaller than that one. From here, it doesn't happen. Alright. Oh, the problem is here. You have to change that one. That's the problem, because here in the second step, x is smaller than 1, so it is less, it is in here I can say if I take the 1 over, so it is changing this one, and when I taking the minus sign again, this changes, so I have to change that one, and then this, now it is correct. That's why I'm confused about. Okay, now it is correct. So this is actually something like this way. So then I can use this one, x squared plus 1 over x minus, I can put 3, because this is greater than this one. Now I have to take care about this part, right? So I know from the previous case, this is actually greater than, from here, using this equation, I can write x squared minus 1 greater than less than 3, right? So this one I can easily write, because I have to say it is greater than any positive number. Now I have to say this is less than any positive number. So then what is my positive number look like? I have to tell x squared minus 1 less than 3m. And I have to tell this as from this one I can take, if I can take x squared less than 3m plus 1, that is fine. So it means your x should be less than minus square root 3m plus 1. This is your final n value you need, right? So now let's write the proof. So first you can write, let n equals the minimum of -1 minus square root 3m plus 1, right? Because this is a positive number, because m is a positive number as well, and m greater than 0. Then x less than -1, this implies your function, this one, x3 plus 1 divided by 2, sorry, x minus 2, this is greater than, you can imply, what is a function? This one, x squared minus 1 divided by 3. And we also have x minus, I can write this n less than or equal minus 1. This implies n less than or equal minus, because we take the minimum out of these two, minus square root 3m plus 1. This is implies x squared minus 1 over 3 less than any positive number. Therefore, for all m greater than 0, there exists n less than 0 such that x less than n, which implies x3 plus 1 divided by x minus 2, this guy, and what about that one, less than m. Therefore, this implies limit x goes to limit x goes to minus infinity, x3 plus 1 divided by x minus 2 is goes to positive infinity. Is it clear? I know it is kind of a bit tricky for me as well, because you had to deal with the negative numbers. Is it clear, or I need to explain it again? Yeah, here, because this one, let's say you need to have this one, right? Someone asking about a question, how you get this one? So basically, how you get this one, right? If you take your real number line, right, you have to have x squared greater than this one, right? So if you take the root square 3m plus 1 and minus root square 3m plus 1, if your x is in this area or this area, its squared going to be larger than this one. So that's how I got this square root value. But since I need the negative value, I consider this part, not this part. Is it clear? Is it clear? Hello? The one more question? Okay. So someone asked me to explain it again. I will just do that question again, just for the sake of easiness. So basically, here, right? So you have to start from this one. And this is your definition, right? This is the definition that you need to prove. And then basically, you have to find some n, a negative number n, where when x is smaller than that negative number, your this value should be larger than any given positive number, right? So then you start with this one. So first, how you start, you see the degree of the numerator is 3, and the degree of the denominator is 1. So what do? I take x out from both numerator and denominator and consider it like this. So then I can have except the largest power of the x, all of the x I have as 1 over or 2 over something, right? Because all the x I have in the denominator, right? It means like once I write this way, right? Except this highest power term, which is going to be x cube, all other terms are in the denominator, right? Because it is very easy, because when you go to the infinity, these terms intuitively goes to 0. It means, although this is have something like this, in higher negative values or higher positive values, this function behaves similar to x squared, right? Then, okay, I will discuss that one as well. And then, basically what you can do from here, first I take x is, I put some n value here, n equal to minus 1. And when I put to n equal to minus 1, I can take x less than minus 1 implies 1 over x is greater than minus 1. Because if you switch the denominator and denominator in the both sides, your equality changed, right? And then this one. Minus 1 over x. When you multiply by minus 1, which is I did the mistake. When you multiply both sides by minus 1, your equal change again, and you have minus 1 over x less than 1. And then you multiply it by 2, it's a simple mathematics, and then you get this one. 1 minus 2 over x less than 3. And then again, you shift the denominator and the numerator, you would get 1 over 1 minus 2 over x is greater than 1 over 3. So it means this whole part is greater than 1 over 3. And using this result, I can straight away tell this guy is greater than this guy. Is it clear? Is it clear? Is it clear up to now, right? Then from here, you have 1 over x is greater than minus 1. And using this result, you can say this guy is less than, because this guy is actually, if you can tell, is less than x squared minus 1 over 3, right? So then it's simple enough, because now you have only one x term in your equation. Then what you have to do is, if you need to tell this guy is greater than m, it is very simple. You can have this guy is greater than m for any given positive number if you have x squared greater than that value. So you have two ranges for x that can this to happen. Is one is x is greater than root square 3m plus 1 here, and the other side is x is less than this minus square root 3m plus 1. So I consider this range just because I need my n to be negative. That's the reason, right? Because I cannot take this one because x is positive. I cannot take a positive value for x. I need to have some sort of negative value to say when x is less than that amount, this result holds. Even though if you consider this range, it is about, let's say, x greater than 3m plus 1. This doesn't need for us. We need something to tell x is less than something that should be a negative value. Is there any specific logic of choosing minus 1? No, I just put minus 1 because it's the simplest negative value that I can take. That's the only reason. If you need, you can take, I would say, minus 100. That's also possible, but I just took the simplest possible number that I can take. That's it. Is it clear? Hello? Is it clear? Yeah, I will share the PDF with you guys, this one as well. My handwriting is not clear, but I will share the PDF as the last time I did. I will share. And also I share the recording as well with you guys, so then you can just watch the recording. Okay. Now someone asked, very interesting question, right? Where is the question? This one, right? Can you discuss this limit? Limit x goes to minus 1, x over x plus 1 does not exist. So first, I would say why this does not exist, because if you plot this graph, this would come something like this, right? So if you come by this one, let's say it is x equal minus 1, this should something like, let's say x is minus 2, it is minus 2, or minus 1 is plus 2, it is something like this and this, right? It should be something like this if you plot this graph, right? So it is discontinuous. It is discontinuous with minus 1, because if you come from the negative direction, it is goes to positive infinity. Because if you put something like, let's say, fx equals x plus 1, and if you put f minus 2, it is equal minus 2 over minus 1, it is 2. And if you put f2, it is equal, not f2, let's say f0, so it is equal 0 divided by 0 plus 1, it is 0. So let's say put 1 or something, otherwise it doesn't mean. So it is half, right? So in the this one, yeah, if it's positive, or there's some no, let's say put minus half, something about like this one. Let's say minus half. If it is minus half, it is minus half divided by half, it is minus half. So it means if this side this is positive, and when it closer to the minus one, in this side it is negative. So it is most of it is something like this, if you draw it, right? Now we have to prove it. So how we gonna prove it? We're gonna prove it is something like this. We assume limit x goes to 1, so minus 1, x over x plus 1 exists, right? So we assume it exists, right? Because we know it is 1. So we have to bring up some contradiction where this does not exist. So do we have done one-sided limits? Do we have done one-sided limits? Yes, you have one-sided limits. Okay. Now, then you can consider this one. So you can consider this one is actually, I think, the left-hand side limit. You can consider the left-hand side limit. It should go positive infinity. And if you consider the right-hand side limit, it should go to the negative infinity. So I would write, then limit x goes to x negative limit, or the left-hand side limit, x over x plus 1 should equal to limit x goes to its right-hand side limit. This should be equal to some sort of a value. Let's say it is, I would say, some sort of a L value, right? So then, by looking at this graph, if you don't want to follow the definition, you can easily tell limit x goes to, if your left-hand side limit is equal to x over x plus 1 is equivalent to negative infinity, right? Not negative, it's a positive infinity. And limit x goes to plus 1, because this plus sign means that it is the right-hand side limit, x over x plus 1 is equivalent to minus infinity, right? So then it means these things are different. So this limit does not exist, right? In another case, if you need to simplify the calculations, you can consider limit x goes to plus 1, x over x plus 1, this is equal to limit x goes to plus 1, so plus minus 1, okay? So minus 1, yeah, this is the way that you need to go, because it is basically, it's not going to 0, it is going to plus 1. And you can easily consider, because you have to, when you go to minus 1, this straight away equal, because we know that limit x goes to plus 0 is, because if you take the 1 over x graph, 1 over x graph is something like this, right? We have something like this, 1 over x graph, right? And here, it's different because we have x plus 1 and x goes to minus 1, it is go to the negative direction. And here, is go something like, because we have x on top of that one. So you can just get the right-hand side limit and the left-hand side limit, and then you can say, okay, this is going towards that direction. Or basically you can tell limit x goes to plus minus 1. So this x over x plus 1 is equivalent to 1 over 1 times 1 over x. This thing that you need to get out of it. So then you can determine, this is going to plus infinity or negative infinity based on your this limit, right? Or else we can write limit x goes to, let's say, we have to this one, let's say x over x plus 1. Other thing is, what you can do is you can use the substitution. Let's say t equals x plus 1. Then this one you can have x equal t minus 1. And then you can have limit t goes to 0, because x goes to minus 1 implies t goes to 0. You can write this as t minus 1 over t, right? So then you can multiply both sides by t. So then you can have limit t goes to 0. This is the most simplest way that you can do it. 1 over 1 minus t over 1, right? So then, you know from if limit t goes to 0, right hand side limit, 1 over 1 over t over 1. This is equal, if you take the right hand side limit, this is equal, this goes to our, from 2 its right hand side limit is positive infinity. So this is goes to towards negative infinity. So limit t goes to 0, if the left hand side limit, 1 over 1 over t over 1, this is equal to, this goes to negative infinity. So altogether, because the minus sign there, this goes to positive infinity. So these things doesn't equal, so limit doesn't exist. This thing is another way, if you can straight away plot this graph, this is another way that you can do it. So both ways okay. So you can choose the best one that you found is easier to you. Any question regarding that one? I'm not going to like prove it by splitting data definition, but if you try to prove, because you can easily prove, but if you have the limit loss of the limit, like the addition and subtraction of the limit, that you can do it. Because we know the limit of function 1 over x, it is a well-known function. So you can just make this substitution to convert this into this limit, right? Limit x goes to 0, 1 over x. We pretty know that limit. So you can just convert back that limit to that kind of a limit by using this simple substitution. Any question up to that point? Hello? If not, I will like, yeah. So I think we do the other tutorial question as well. And yeah. So, yeah. So someone has sent me a question from a quiz, but I don't think it is quite, I would say, appropriate right now, because I will discuss it after all the quiz has been finished. But for now, I think I can avoid a little bit. Oh yeah, in the case, we should prove the one-sided limit using the limit definition and then show that it is not equal to the limit doesn't exist. I don't think, because usually the limit definition questions come in a way that if you need to prove the limits, once you prove that one, because basically limit definition is there to define the limit. So definition is a very basic to you define something, like it's a, I would say, pretty much basic thing how you define this limit, right? Fx. And then built on this definition, you have limit loss. Let's say fx plus gx if you have limit, and then you can have simply take L plus M if the limits of fx and gx is L and M. And if you have the ratio, and this kind of this result is proven by the definition. So you can use that result. Based upon that one, you have another result called, you have another things called limit, the left hand side limit and the right hand side limit. So this is another set of limit definitions, and you can prove it if limit exists, both two things should be equal. It is a result. Once you have that result, I think you can use that one, because you don't need to perform all that from scratch. It depends on the question, because if they ask, show that this limit doesn't exist, and it need to you to use the get the left hand side limit and the right hand side limit and show that they are not equal. And for that, to show that the each of the one-sided limit, you don't need to definition if they if they are not specifically asked for it. But if they ask to prove by definition, it's another story. But usually what happens is, if when they are giving like the essay type question, I think you don't have to worry about that one. They will give prove this one-sided limit, prove this one-sided limit, and then as a one sub part of the question, they okay, based on this above result, show that this limit does not exist. So then usually they should guide you. But for if they simply ask show that this limit doesn't exist, then you just have to take two one-sided limits and just evaluate it without using the definition by the simplest term, and then tell them, okay, this limit doesn't exist. So you can use some simpler technique like this one to do that one. But it depends on the question, basically. If there's an interval as 1 over root 2 in Riemann integration, is it Riemann integrable? Yes, because it is just two real numbers, so it is interval if there's interval. But only problem is if you have some interval with, I would say, infinite limit point, then it is not Riemann integrable. But for this case, it is Riemann integrable because it is just two real numbers. It's because Riemann integral is definition like something like this way, so it is no restriction on these a and b when they are real numbers. They can take any arbitrary two real numbers, and then you can take the Riemann integration. That's it. Anything? Oh yeah, one side limit consider one side, so should fx also a left or right side notation like limit. Yeah, one side limit consider one side, so fx also left or side. No, you don't have to have, because usually we don't put like that way. Usually I only put the notation to uh, the x equal this part. Let's say this plus, so x equals minus, and we don't usually put to fx to plus or minus. We don't do that in usually, because usually function is defined for the whole domain. So basically, we don't need to explicitly do that one, but some textbook may do. It depends on the definition, but usually I would say I normally don't use that one, because if you use L plus or minus, how are you going to use something like sine function, right? Because in sine function, you have in the both sides. There's something called spike function, kind of, so you cannot do that one. But yeah, basically this notation that I'm most familiar with, but I'm not seeing like anything like L plus or L minus. But I haven't seen, but I have to look them for. But it depends on, like, if they are given in the note or some definition for that one, you have to use, but it depends on the definition exactly. Any question up to now? Oh, you can just ask. And let's see what are the other questions that we have. Okay, so if not, like, yeah, this is actually the infinite limit, and then I think I will. I think I have some detailed video on this one, as not this question discussion for this limit definition. I have a very detailed video in my YouTube. I will share it with you guys as well, with the limit definition, how you can write the limit definition, and also the how you handle the infinite limits, and also the one-sided limits. As I remember, it is there, but it is in single. That's the problem. But I will share it with you. And the other thing is, like, when you are like dealing with this limit question, even with the sequences and series, make sure that you are familiar with this limit definition, because it is going to be appearing everywhere, uh, specifically when you are dealing with the convergence of the series or sequences. So that is pretty much that you, that is actually the main thing that you have to remember, is the actually basically the limit definition. What does this mean, and how does it can be written, and then how you can change it. So then you don't have to remember either of the definitions of the series convergence or sequence convergence. So that is pretty much. So then today, actually, I will be going to be end up a bit early because I haven't had my lunch yet as well. So yeah, so if you have any question, you can just WhatsApp me, and then the next week we can have more questions. And also regarding the academic stress and the workload management, we can arrange some session somewhere around next week. I will just find some resource person for that one. And because previously we have some good resource persons, because I need to get some professional resource person for that one, because previously we have someone like very reputable person. I will spell out you the name in the chat, and let's see how we can arrange that. Because if I can get that resource person, then I think that's going to be really good. Because last time for the 22nd batch, we get that person. Also 20 batch, we get a couple of times, but I just have to reach out to them and ask whether it's available or not. Okay, so we can wind up for now. And if you have any question, just you can put me in the WhatsApp that I will answer. And thank you for joining. Bye-bye.